Jose Alatorre. This is the presentation for the final project. The topic that I choose is improve investments, and what I'm going to do is I'm going to explore if the Google Natural Language Sentiment Analysis API can be used to explain high-frequency stock price movement in the Standard & Poor's 500 oil and gas sector. So this is a little long of a title, but I will go slowly and explain what's the objective and what's the motivation of the project. So let's start now. So project objective. The objective of the project is to explore if it's possible to explain stock price movements in the oil and gas sector using sentiment analysis provided by Google Cloud Natural Language API. So sentiment analysis, what's sentiment analysis? Well, sentiment analysis is the process of computationally explain and identify opinions in a text, right? So it's, if we see a text, if we read a text, we as humans can interpret not only what the text said, but if the author is trying to give a positive or a negative feeling in the text. So Google has an API that they claim they can provide this sentiment analysis. They can classify any text in positive or negative, and they can assign a value to this classification. We will see later how this classification can be interpreted. The importance of finding a relationship between the news sentiment and the stock price movement can be very beneficial in the design of trading signals and trading strategies. For example, if we can actually measure a relationship between the movement of one particular type of stocks and the moment that news arrive, then we can try to see if this happens in all stocks. Maybe some stocks react faster, maybe some stocks react slower. So then we can do a trading strategy when we sell the stocks that have already reacted to the news, and then we buy the stocks that has not reacted to the news. No? Like that's one example of why this is a very important topic, and then can bring a lot of research in designing trading strategies. So project outline, first we're going to talk about the technologies used. These technologies used, as I mentioned, are two APIs. The first API is the news API. This is an API that allows the user to retrieve news from over 3,000 news sources and blogs. And the second API that we are going to use is the Google Cloud Natural Language that, according to Google, allows to extract information about people, places, events, and much more mentioned in text. One sub-function of this Google Natural Language API is what Google call the sentiment analysis, and is the one that we are going to use to try to find a relationship between this sentiment and the stock price movement. Okay. So News API. How to use News API? Very simple. The installation is straightforward. You just need to go and pip install News API. The functionality also it's very simple. There is a Python API that you can just select which keyword you want to use. In this case, we are selecting, for example, oil. We are selecting a date range, and we are selecting a language, English. So this function is going to retrieve all the news from all the sources available in News API on this date range. It's also important that if you want to replicate this exercise, you need to go to News API and create an account and insert your API in this function. Now, what happens when we make a request on News API? Well, what we get is these old articles that we define here. We are going to get a dictionary with 3 keys: status, total research, and articles. So if we actually look in articles, we can see the fields that each article contains. In this example, we can see that it has an author. We can see a description of the content, like this is probably basically the headline, description of the article, that it's except from the full article, and the publication date. This is very important because we are going to try to match, of course, this exact publication time with the movement in the stock prices at that exact time. We will go down further. Then the second technology that we will use is the Google Cloud Natural Language API. So the installation here it's a little bit more complicated, but still straightforward. First thing is you need to pip install Google Cloud Natural Language. In the case of our CentOS that we have been using in class, I needed to add the ignore install because there is some dependencies that are not that can cause some problems if you don't ignore those dependencies. But for running the example, there will be no mistakes. Now, second thing, after installing the package, you need to create, of course, an account in Google Cloud, and then enable the natural language API. Google gives you around 5,000 text analysis per month for free. So we have 5,000 requests for this example that we can use for free, and then and see if it makes sense to actually keep using this analysis. Also, the way that Google APIs authenticate, I don't know for the ones that are familiar with this, you need to download a file and update the credentials in the path. The full description of how to do this can be found here in this link. Okay. So the functionality of the Google Cloud Natural Language is also straightforward. We're gonna create this function that is gonna make a request according to some text, and we're gonna get this JSON object. That the two important, well, Google provides many details, but what we're gonna focus in this project is in these two fields, the magnitude and the score. So what's the magnitude and what's the score? Well, the score it's a number between -1 and 1 that tells us how positive or negative the article is. If we have a -1, it means that the article is negative, and if we have a number 1, it means that the article is positive. And then the magnitude measures how positive or how negative was the article. So for example, if we have, according to Google website, if we have a score of 1 and then we have a magnitude of about 3, it means that it's a very positive article. If we have a very small magnitude, even if we have a positive score, the news is not or the text is not considered as positive. The magnitude goes from 0 to infinity, so basically the magnitude is like a scaling factor to our score. Okay. So now going through the data that we're going to have using these two APIs, we have the news data. News data API only allows us to get news articles for a 1 month period and also 1,000 requests a day. So we are only going to use 1 month from the 24th of October to the 24th of November. That was when I started doing the project. And I'm gonna do 2 requests. I want all the news that contains the word oil and all the news that contain the word stock market. If I do this request, we are gonna be working with around 2,000 articles with 1,000 almost on each type of keyword, like oil and stock market. Now for the intraday stock prices, I use a Bloomberg terminal. For whoever that are not familiar with finance, the Bloomberg terminal is a service that Bloomberg provides that allows us to get a lot of information, and one of these is intraday prices. I'm getting a 1 minute window for the 30 stocks in the S&P 500 oil and gas sectors. This time period, if you look at the 1 month, that is what we are using in the news. On 1 minute time frame, we're gonna have around 15,000 stock prices for each stock. So we can see that the level of data is quite considerable. Okay, there's for the ones that are more interested in how the project is done, like you can replicate with all the excepts that I'm putting here in the code, and also from the report. Now, analysis description. So what's what I'm doing in this project? Well, what I'm doing is I'm gonna do a linear regression, a simple linear regression between the score and the magnitude. And then I'm gonna try to explain the returns in 1, 5, and 10 minute windows. And if and according to what we're expecting, well, we think that if there is a news that's gonna affect the future cash flows of a stock, then the price of that stock should have a change. That's just fundamental economics of pricing of stocks. So we hope that we can find this relationship between Google Cloud natural language API and stock prices returns. So this is the code that I use for creating these rolling regressions. Remember that we need to do a regression for each stock. That's 30 stocks. And then we're also going to do a regression in 1, 5, and 10-minute window. This with the objective of see how fast stock prices react to news. What are the results that we have? Well, before getting into the result, let's recap what we have done. We're going to do a regression. We're going to evaluate the regression using the R-square to have an idea of how good was the fit. We're going to do a regression for 2 sets. One for the set of news that contain the word oil, and one for the set of news that contain the word stock market. These regressions are going to do for stock price returns in 1, 5, and 10-minute windows. Something that it's important to mention is that even that we are using a very simple model, a linear regression in a test set that is 60% of our new sample, and only 15 days of news and 30 stock calculation for 1 minute. Our CentOS part took quite of a time. It took 2 minutes to calculate all the regressions. It may not sound a lot, 2 minutes, but if we start thinking that this is only 15 days, we may want to run this strategy not on only 30 stocks, but we want to do like worldwide, and we have the Russell with 2,000 stocks. We're going to have a longer period of news, and it's clearly that we really need big data analytics and big data force to analyze this type of experience. No? Okay, so now let's go to our results. Sadly, the results were really not satisfactory. We got R-squares consistently close to 0 for both sets of news, as we can see in the next tables. This is when I use the word oil in the news, and this is when I use the word stock market in the news. As you can see, really all R-squares are consistently close to 0. I'm not putting the 30 stocks here, but you can verify the experiment with the code, and then you will see that all the stock prices are close, all the R-square are close to 0. So, more than concluding that the Google Cloud Language API cannot explain market movements, I think we need to go back and believe how are we set up the problem, right? What does means positive and negative for Google, and what does mean positive or negative for stock price? So let's look at one example. If I use the text, Saudi Arabia is ready to increase their oil production by 500,000 barrels. Well, this clearly will be a negative news for the price of oil and for oil producers companies. However, Google uses a score of a positive. If I only change the word to decrease, this should become a very positive news for oil producers' stock prices. And indeed, Google score change the score, but we have a positive score for something that should be negative for stock prices, and a negative score for something that should be positive for stock prices, right? So first is like, okay, should we see a negative coefficient probably in our regression? That's one thing that could help us explain peers, but the only problem that we have with this is that we don't know what is positive and what is negative for Google, right? And also we don't know if we have stocks that are oil producers and oil consumers. So I think it's not a matter that Google is not explaining correctly the sentiment of an article. It's more a sense that we need to rephrase the problem, and we need to think that oil is not enough of a word to only find things that are positive or negative to stock prices, right? Statistically, we can see this. Well, this is a description. Statistically, we can see this. For example, if we plot for one stock, actually I'm using the all or an index of all the energy stocks. We can see there's not like a clear relationship between the level of the score and the return that is on the y-axis. Same is for the magnitude. So what I did is to think, okay, maybe some news that are not as positive or are negative has no impact on the stock prices, but maybe news that are like really positive or really negative have an impact in the stock prices, right? So let's look at what we get if we put a threshold. I just use an arbitrary threshold of 0.3, and let's see what happens with stock returns when I use a threshold of 0.3. So when I use a threshold of 0.3, I can see that most of the returns were actually positive. So it seems that actually Google is telling us that when we have a very strong score, it seems that this impact news. So this is very positive because it leads our analysis. However, we only have very few data for each individual company, and given that we have like around only 3 points or 2 points, I would like to keep this study with more data. So I think one of the conclusions or the main conclusions of this project is that yes, there is an opportunity to improve investments using Google Natural Language API, but we need to have more data in terms of news. We probably need to pay the news API or find another source when the news can be obtained easier. And of course, this relationship, this probably transforms not into a linear regression problem, but also into a classification model. So if we are going to have more data and we're going to have a more complex model, then of course we will be in the need of having more computational power, as we saw with the time that took to do this simple model. And then Spark will be a very useful tool for this analysis. So, well, this whole presentation, hope was not too boring, and hope was interesting for you guys. I think it's actually very interesting results. So if you have any questions, please send me an email. And well, happy to see your presentations. Thank you.